Firstly, in this first example, I've got two fair six-sided die. When you have got fair die, just remember that fair and unbiased refers to the same thing. And there's a difference. I'm going to show you two questions. First one, we do unbiased first. Then X is defined here to be the smaller of the two scores if they are different numbers, but the common value if they are the same. Can we try to construct this table first? And this table that I'm looking at is actually trying to list all possible outcomes. Usually when we have two objects being thrown, I will suggest that we draw out this table first of all the outcomes. Meaning I'm looking at the top here is die 1, this is die 2. Just try to write down all the outcomes so that you understand the problem better. Okay, so die 1 and 2 will be 1 to 6. Okay, so both let's fill in 1 to 6 first. Hence, there will be 36 possible outcomes. Okay, they mentioned that X is defined to be the common value if they are the same. So we fill in that first. These diagonals will all be 1 to 6. If they are the same, it's that common value. But it will be the smaller of the two numbers if they are different. So over on the first row and first column, everything is 1. The smaller of the two values is 1. Same for the first column, everything here will be 1. Okay, hence, we should also understand now that the next row, smaller of the two numbers will be 2. Same for the next column. And we can keep extending this to 3, 4, and 5. Okay, so what do they want us to find? They want you to find what is probability X is 2, followed by a distribution. The reason why I wanted to emphasize on this is unbiased die is because then each of these cells, or let's write here, each cell is equally likely. Since you have two unbiased die, every cell will have the same chance of occurring, which means that their probability is 1 out of 36 for every single cell there. So if we are looking at calculating X is 2, we will just be calculating how many cells there are. Okay, the number of 2's here will be 9. Hence, we can conclude that if I want probability P of X equals to 2, since we have 9 cells, we are going to take 9 times 1 over 36, which is 1/4. Okay, so the rest of the values in the distribution, we try to fill in. So you have X and probability X equals to X. Take note of the notation. Okay, on the top is small letter. At the bottom is capital letter X equals to small letter. So we have 1 to 6. Okay, notation important, small letter X at the top. I just fill in for that one value that we know for now. X is 2 is 1/4. Okay, for the rest, let me just leave it blank. Easy to calculate. Okay, so next one, when you want to find expectation or variance, I have a reminder there that when you calculate these two values, by default, you can use the graphing calculator. Unless the GC don't give you exact and you want exact, then you use formula to help you. Okay, expectation variance for discrete random variable are with GC. I have it on the next page. I will explain the second example later on. Okay, so even though I have listed the solution here down for you, I need you to remember all this can be done on the GC as well. GC will be the default method so that you get answers quickly. Okay, but part 3 is a slightly different problem for the discrete random variable. They now have this game to be played between Ivan and John. We're going to take turns to throw your 2 die. Ivan goes first. And first player who gets X is 2 will win the game. If Ivan wins, John will pay 7. If not, Ivan pays John 10. So basically played between two players. The first one who gets two will win. Can we check who has got the higher expected gain? When you see the phrase expected, it means that you are supposed to get expectation of gain, but you haven't defined any gain yet. The initial variable given to us wasn't a gain. This is basically calculating these instructions here. So you will now therefore need to get a new variable. If you want to find expectation of something, it means that you need a variable based on that. Okay, so based on this context of what is gain. Okay, hence, can we define something below? Okay, let's work out part 3 here. I do it in the bottom. In order to get expectation of gain, let's define. I need to define for someone, that's Ivan and John. So I'm going to say let Y be Ivan's gains. Let me construct a simple table. Okay, I will just draw the skeleton out. So you will have Y, probability Y. What are Ivan's possible gains? Ivan can win $7 or Ivan can pay John 10. So if Ivan wins, Ivan is going to win $7. But if he loses, then that will be regarded as a negative 10. Okay, so you want probability of these two. Let's try to calculate how Ivan can win. So if Ivan wins, how does someone win? He will win if you get a value equals to 2. And value equals to 2, chance is 1/4. Okay, so if Ivan wins, means he can win right at the first round without John winning. It's played between Ivan and John. Ivan goes first. Or he can lose the first round. It's going to be very similar to the A-levels question we did last week. Or John plays, John loses, followed by an Ivan win. We continue. And we can start to see this will be a sum to infinity. So Ivan winning is 1/4 chance. Not getting a 2 will lose. So this will be 2 losses. Loss probability is the complement. So we get 3/4. Followed by another 1/4. Oh, this is power 4. Then 1/4. This is a sum to infinity for a GP. We can easily see the ratio. Your ratio is going to be 3/4 square. So let's apply the sum to infinity formula. First term 1/4 over your 1 minus R. And this gives me 4/7. Okay, since this game just has 2 outcomes, Ivan winning is $7. So this is 4/7. Hence, the other one you don't need to calculate must be the complement since they add up to 1. So the other box will be for 3/7. So why are we doing this new distribution table? You want to calculate expectation. So from here, I can calculate expectation of Y. Expectation for a DRV is you multiply and add up the values. So we have 7 times 4/7 minus 10 times 3/7. This value is a negative number. Now, we don't need to write down the interpretation, but I want to help you. Let's say you have explanation questions. How do you describe such an expectation? This is actually the average gains for Ivan. which means on average, he loses since this is a negative value. And he lost to who? The game is played between John and Ivan. So if I want to calculate John's gains, who did Ivan lose to? He lost this amount, and the amount is lost to John. So if he lost this value, John will gain the same number. You don't need to calculate John's gains. Anything that Ivan loses must go to John. And hence, who has a higher expected gain? I can then say John has a higher expected gain.